Okay,
here we go. Challenge accepted. 5.4 is learning the properties of logarithmic functions. You're learning the expansion and condension properties. How to take a condensed log and expand it out into multiple terms. How to take a expanded log in multiple terms and condense it down to a single log with matching bases. Make sure you're staying with me and not trying to work on something else. You need to recall the conversion between a logarithmic equation and an exponential equation. Also, keeping in mind what it means to solve either one of them. Also, remember these special cases that ln can be rewritten as log base e, and that the ln of e is 1. So keep that in mind because this is going to pop up. These are identities that are going to help you in rewriting these logarithmic expressions. Okay, go to the next slide and you're going to see all the properties of logs. It is a lot. We've got the product rule, the power rule. Then we turn to the next slide. We've got the quotient rule. Very similar to properties of exponents. So that should look familiar here. Let's start with the product rule. This is the property of exponents product rule. If you have a base to a power times the same base to a power, you can condense it as a single base to a power, and the power changes by adding those exponents. And if you think back to properties of exponents, we refreshed this in chapter R. I said that if you can see both bases, how many strokes of the pencil does it take to make a plus sign? It takes 2. So I see 2 bases, so you add the exponents. In terms of looking at an action, like that's the formula, the generic formula. Here is an example. If we had 2 cubed multiplied by 2 squared, 2 cubed times 2 squared, don't evaluate it, that's cheating. Write it as a single condensed base to a power. The bases match, which means I can write it one time. I see both bases, so I add the powers. If you forget that, just go back to expanded form from the very beginning. 2 cubed means 2 times 2 times 2. 2 squared means 2 times 2. Well, how many are there? How many 2's are there? There's 5. So if you forget the rule, write it in expanded form, and common sense will remind you of the rule. What does it look like with logs? You need a highlighter. It would really help here. If you notice, this says log base A. I want you to think of that as a block. Log base A. And then the of part is what changes. Okay? If I have log base A, and notice I have 2 things being multiplied. This is m times n. So the way you read that is log base A of m times n. If you need to, you can put parentheses in here. I'm trying to write it to blend in. You can put parentheses in there. That looks terrible. There's no way to do it. There we go. I changed the pen. So log base A of m times n can be written out in expanded form. This is called expanded form. Notice, this is where your highlighter is helpful. It is log base A for both of them. The expansion part is we take what's in the parentheses and we write it out, and the operation in between is addition. So it's the same mindset as properties of exponents, okay? So if I see log base A of something being multiplied, I can write it in expanded form as log base A of the one thing plus log base A of the second thing. Might want to emphasize the plus sign because that's the rule here. That when they're being multiplied in expanded form, it becomes a plus. So let's look at examples. Express as a sum of logarithms. You've got to learn how to read the directions and know what it's asking for. It wants you to take it, write it out as a sum of multiple logs. They're literally guiding you to write it in expanded form. So look at it. It's log base 3 of 9 times 27. Take your yellow highlighter, highlight the log and the base. That is the first part of your expanded form. So it's going to be log base 3 of something plus log base 3 of something. The something part comes from the parentheses of 9 and of 27. It says express it as a sum. Yes. If it said evaluate it, you would have to think to yourself what those logs represent. Notice there's no x, so everything has a number. So this is saying 3 to what power is 9? 3 squared is 9. This would be a 2. And then 3 to what power is 27? Well, if 3 squared is 9, 3 cubed is 27. So the answer is 5 if it said solve it. It didn't say solve it, though. It just said to write it as a sum of logs. This is in expanded form. I need to write it as a single log. They have to match in bases. Log base 2, log base 2. So as a single log, it would be log base, wait for it, 2. Now I have multiple things fixing to come together, so you need to put parentheses, and I just write what the of part was. It's p cubed and q. You don't have to put the multiplication dot there, since it is 2 variables, but I did put it there. Okay, that's the product rule. That is taking a log base something, 2 things multiplied together, and expanding it out as addition. Now we're going to look at the power rule. The power rule, going back to the exponents, if you have a base and a power, follow me, to a power, then the rule in the exponents properties is that you multiply the exponents. And the way that I taught y'all to remember that is this parentheses right here, parentheses means multiply, right? So the exponents are side by side, separated by just that little parentheses, and that's your reminder, hey, you're multiplying. Also, how many strokes of a pencil does it take to write a multiplication? 1, a dot, right? Don't say, well, an X takes 2. Don't do that to me. A dot. We're moving out of the X as a multiplication. College, you don't put the X there when it's multiplied. You put a dot. So this is the rule with exponents. Here's an example. If we had 2 cubed squared, think in expanded form, that's 2 cubed times 2 cubed, which means how many 2's are there? There's 6. So the faster way to get to that is to say, I see one base, so it's 1 stroke of the pencil. They're separated by parentheses. I multiply the exponents. All right, how does that relate to logs? Here's the power rule for logs. If you have log base A of m to some power, you've got to follow everything I just said. You have log base A of m, but to a power. There's a lot going on here. You got a sub number. You've got the base of the power, and then you have the power. So you have 3 levels there. The expanded form, okay? Notice where the P went on the right side of this. Where did it go? It moved to the front and no longer in a power position. Now it's like a coefficient, right? I want you to draw an arrow from this P to right there to represent like where it's going. If you have a different highlighter, that would be great. I can do this, so I'm going to erase mine. If you don't have, I know you can't necessarily erase your highlighter unless you buy the ones that erase, and they do erase. But you could highlight in a different color the P, and then highlight in over here in that color to represent where it moves. It moves to the front. It becomes like a coefficient. So it's multiplying times the log. All right, coming over here, express each of the following as a product. Meaning you should have something times something. The exponent needs to move to the front. You will see me draw that arrow every time because it reminds me what to do with it. Move to the front. Okay, I would encourage you to draw the arrow. Please don't turn your nose up at something simple like that. This will become -3 times log base A of 11. For this particular set of examples, when it says express each of the following as a product, it means move the exponent to the front. Now, if you look at B, you might be thinking, well, there is no exponent. But there actually is. They just don't have it in exponent form. What's the exponent here? 7 underneath a 4th root power can be rewritten as 7 to the 1/4 power. And then now I can move the power to the front. So 1/4 times log base A of 7. I should have changed the thickness of 7. All right, we have ln of x to the 6th. Don't let the ln throw you off. If you want to write log base e, you can, or you can just leave it. The same rules apply here, though. This is of x to the 6th. The power moves to the front, so it becomes 6 ln of x. That's the product rule, the power rule. Now we have the quotient rule. Then the remaining slides are, in my opinion, challenging problems. It just dives right into the level 4. We don't start simple. We just go right to straight to the challenging stuff. All right, so go to this slide. Let's refresh you on the quotient rule with properties of exponents. Can you see what I'm writing if I'm on this thickness? Okay.
Kinda.
Because the other one was driving me nuts. So looking at the quotient rule of properties of exponents, if you have a base and a power and a fraction over the same base and a power, then you can condense it to a single expression, same base, and you subtract the exponents. And if you learned this, if you remember from chapter R, I said it, but if you had Algebra 2, hopefully your teacher said, hey, by the way, think of the fraction bar as a subtraction bar to remind you of what to do with the exponents. Okay, so I made my fraction bar thick here because I'm trying to emphasize, like, here's a tip for remembering what to do. All right? So, for example, let's look at it. We are going to put 2 examples in here because there is an order to this, right? There's an order to it. So we're going to do one of each scenario. There's 2 scenarios. The first scenario is going to look like this. 2 to the 4th over 2 cubed. The second scenario is going to be 2 cubed over 2 to the 4th. So what's the difference between those 2? What's the difference between those 2? Yeah, it has to do with the exponents. If you think of which one's bigger, in the first example, the higher exponent's in the top. In the second example, the higher exponent's in the bottom. The location of the higher exponent matters. The way that I recommend simplifying this is you always find the smaller exponent, you circle it and say to yourself, I'm going to move that up here to where the bigger one is. In this case, it goes up. And I'm going to say 4 minus 3. So this would be 2 to the first power. Now, notice the second example. Find the smaller exponent. It's right here. I'm going to move it down, and I'm going to put minus 3. I'm going to come over here, and I'm going to keep in mind where I was just saying it's going. It's going to the bottom. And then, of course, that leaves the top empty. It can't be empty. There's an understood 1. Look at the difference between the 2 answers. Now, that was a refresher on exponents. The good news is with logarithms, the order is always the order that they're written. The first one will be in top, and the second one will be on bottom. You don't have to worry about which one's bigger and smaller. But that is, you should know that in terms of properties of exponents. That should not be new. So let's come to the quotient rule for logs. Your highlighter would be helpful here. I'm just trying to get yellow. There we go. All right. Log base A of m divided by n in expanded form is log base A of m minus log base A of n. So this is expanded form. This is in parentheses. It's understood to be in parentheses, or sometimes you will actually see it in parentheses. This is always going to be a fraction when you are using this rule. Whatever is in top will be written first, minus whatever was on bottom. So the minus sign, I'm going to emphasize that because that is the expansion. So if they are being divided, you expand it out to be subtracted. Okay, 2 practice problems. It says express as a difference of logs. They're literally telling you right here, hey, you're subtracting. Express as a difference. We have, and they're also saying you should have multiple logs. We have log base t of 8 divided by w. So I'm going to write it as log base t of something minus log base t of something. The something, the of part, comes from the order of the fraction. 8's on top, w's on bottom. The next one is in expanded form, where you're going to condense it to a single log. Bases have to match. They do. If they don't match, you can't condense it. You would just retype that as the answer. But they do match. So we have log base b. You write it one time. Remember, think of that as a block. Log base b. And then now you look at the of part. We have 64 and 16. It's a subtraction, so to condense it, it would become a fraction. You can write it like that, or you can put it in parentheses. It's up to you. It did not ask us to evaluate, so we don't have to do anything with it. Really hope y'all are paying attention. I keep seeing, just, if you're not, I don't know, it doesn't look like you're paying attention. All right, so now we've got this right here is telling you common errors. So if me saying, hey, watch out for this messes you up, then tune me out right now. You have permission to not pay attention. But if hearing, hey, watch out for this is helpful to you, then tune in. Notice right here, it says log base a of m times n does not mean, oh, I'm just writing them out in 2 logs and I'm still multiplying. Notice, so this expanded form changed nothing, right? That's the error here. They took what was multiplication in dot form and they just put it in parenthesis form. That's wrong. You should always be going from one operation to a different one when you're expanding and condensing, okay? And the connection is multiplication goes to addition, vice versa. Fraction or division goes to subtraction, the ones that rhyme. A fraction goes to a subtraction. And then a power comes to the front as a coefficient. Those are the 3 categories. They said the same thing here. Like if I said, hey, here's a single log with 2 things being added, that does not mean, oh, I'm just going to add them then as 2 different logs. That's wrong. Nothing changed here. It went from addition, it's still addition, so this is wrong. Here, same thing. It went from here's a fraction and they just made it a bigger fraction. Wrong, right? This right here, when you first look at it, you might be thinking, why is that one wrong? What is the power actually being raised to? Like, what's it raising to the power?
The whole thing.
The whole log, where we looked, if you go to the last slide, the power was only on the of part, right? So that would be incorrect here. This is not m to a power. This is the entire log to a power. So you cannot apply the rule we just learned because it's totally different, okay? All right. Go to A. So you don't want to write big. In fact, I have like a note to myself. I really need to space this out because so people can write big. But look at the directions. It says express each of the following in terms of sums and differences, which means that the multiplication, what is it? Sums and differences. So, yeah, the multiplication is becoming addition, and the division is becoming subtraction, right? Yeah. All right, so let's look at A. We have, here's where it would really help if you use your highlighter, because you will notice that this is a single log base A. right? So our answer should say what for every log? Log base A. If you'll highlight it and treat it like a block, it's kind of supplying you with the beginning of every log. It's going to be log base A, log base A, log base A. The part that you have to actually look at, tweak, work on, expand out is the x squared y to the 5th all over z to the 4th. That's what you're going to have to break apart and write out in expanded form. How do you know when to stop? You should have no exponents and no multiplication or division. Everything should be just like it says right here, sums and differences, meaning plus and minus signs. Okay? All right. So what do we have first? We have x squared y to the 5th over z to the 4th. What would be the first technique for trying to break that apart? What's my rule always? Get rid of the fraction, right? Let's get rid of the fraction, because then I can work on the top, then I can work on the bottom. So what would be tell me what separates to get rid of the fraction? Yes, the fraction becomes subtraction, and it's literally between the two things you see in the fraction. So copy your, I guess you can see it. Copy your log base A. Remember that was your little like stamp. Got to be at the beginning of every one of them. What's on top? Okay, and that's a lot of stuff. So what would be smart to put there? Parentheses. And then what do I write? It's the fraction becomes subtraction. Stamp, next log. What was on bottom? Z to the 4th. I don't really have to use parentheses there because that's just one term. Granted, it's to a power, but it's just one term. Once you have it as of one term, if there is a power, now you can take care of the power. So, coming in here, I see this is log base A of z to the 4th. I need it to be log base A of z. The 4 goes where? To the front of just it, correct? So I draw my arrow, and that lets me know as I'm writing my next line, I'm going to now write minus 4 log base A of z. All right. Also, looking right here, how many terms are in these parentheses? 2. What are they attached by? Like, what's keeping them together? Multiplication. Multiplication becomes addition. You need to write that somewhere. I don't know if you want to put it on the last slide, maybe. But multiplication, draw a double-sided arrow, and addition go hand in hand. That doesn't look like a plus sign. There we go. Division and subtraction go hand in hand. And then the power comes to the front. That was a little different, but okay, so we have x squared y times y to the 5th. They are attached by multiplication, so I'm going to separate them by addition. Remember the block. This is log base A of 2 things being multiplied, so it's going to become log base A of something plus log base A of something, right? And then what goes into somethings? What goes there? Let me draw that in a different color so you can actually see. There we go. All right, so x squared and y to the 5th. Now I'm going to copy the minus. I'm going to take note of my little arrow saying, hey, bring that to the front. Okay, now what do? Is it done? Not done because you have exponents in there. You can't have exponents. So now what? You're going to pull the exponents to the front of each of those logs to be a coefficient. Alright. So I'm going to take my arrow and I'm going to make a note to myself. I'm pulling that forward, I'm pulling that right there, and now I'm going to write it. So 2 log base a of x plus 5 log base a of y minus 4 log base a of z. That is the single logarithm expressed as 3 individual logs. Yeah. The hardest part about this is just you get overwhelmed. You think that there's just too much, you don't know where to go. Be strategic about it. If it's a fraction, break it apart. Get rid of the fraction. Then focus on the top, then focus on the bottom. The powers are last every time when you're expanding it out. All right, let's try the next one. We have log base A. So I'm going to highlight that, and that's my little stamp for every time I'm expanding this out. We have the cube root of a squared times b all over c to the 5th. Right? You with me? You can't do anything to the fraction because it is protected underneath a radical. What can you do with the radical? Yes. Let me get it to 1/3 first, and then we can do that. I'm going to rewrite this as log base A. I've got a squared b over c to the 5th. And all of that was raised to what power? 1/3. Goes back to that example we did that was the seventh root? No, 4th root of 7. This is a 1/3 power. It's 3. Okay, the idea is to break the fraction up, but that entire fraction is being raised to what? 1/3. So in this case, the power's in the way, right? So what can we do with it? Where's the power go? You can either distribute it into the parentheses, or, watch this, or you can say, okay, that's going to come right here. And it'll tag along for the ride, and then at the very end, it will be in front of every single log. So there's multiple ways to do this. I pulled it to the front because I didn't want to deal with 1/3 in the powers up here, like with this. I wanted to wait and deal with it at the end. All right, this gets lengthy, so instead of coming underneath, I'm actually going to do another equal sign from over here. So this would be 1/3 times log base A of a squared b all over c to the 5th. Now, as you highlight right here, I need you to highlight the 1/3 as well. If you do this technique where you pull the 1/3 to the front as a coefficient and you hold on to it till the end, you have to remember it's there in front of every single one of them. Okay? Now, I've still got this fraction. I need that fraction to be broken apart. Fractions translate to, rhymes with it, subtraction. So I have 1/3 log base A of this crap. I'm going to rewrite it as 1/3 log base A of the top minus 1/3 log base A of the bottom. You with me? The top, A squared B minus 1/3 log base A of the bottom. Y'all with me?
Mm-hmm.
Come on, y'all. It's only 30 minutes of teaching. Come on, focus. Stay with me. Now what do I do? What's one thing I can make note of for the next line? What? Yeah. So this right here that's in parentheses is being multiplied. Multiplication translates to additions. We can separate them. Your block, 1/3 log base A, is now fixing to get written twice for that first expression. So we've got 1/3 log base A of A squared plus 1/3 log base A of B. Look, the block 1/3 log base A, like I said, is now in front of every single one of them. So don't let that throw you off. It's like a stamp. You know what I mean? And all I'm doing is going in and separating what's in the parentheses. That's the manipulation part. Now what about over here? I got minus what? Bring the 5 here. Now be careful. Please don't add it. What's 5 times 1/3? 5/3. Am I done? No, what's left? You have this 2 right here that's got to go here. Now, instead of having to rewrite the whole thing, if it's getting crowded, because you can see mine's already encroaching on the next problem, you could just account for what's it going to become. It's going to become 2/3. So I could, if it were me and this is bothering me, I would be like, okay, so I know it's going to become 2/3. I'm going to erase the 2. I'm going to erase my arrow because that would, the screen's shaking. Hold on. I would erase the 1 and I would write that it's a 2/3. And that would be the answer right there. If you had distributed the 1/3 up here, right here, like Jack did, you would have had along the way a 2/3 power, a 1/3 power, and a 5/3 power, which is perfectly fine. But you can see why I chose to just pull the 1/3 to the front and wait to the end. But it does not matter. Both of them work. Next slide. Not next slide. Next problem. Did I make it a new slide for y'all?
No.
I didn't. No. Okay, if you wanted, you could move to a blank spot and copy the problem. But we do have this last slide right here. Last problem. Log base B of this mess. Log base B of this mess. All right, highlight your stamp. meaning your log base, what's the first thing you want to do? It's a fraction, change it to subtraction. Get the fraction broken up so you no longer have a fraction. So it's going to be log base b, the stamp of the top, minus the stamp of the bottom. Think of it in terms of that so you don't get lost in the actual letters and numbers. So, stamp of the top minus stamp of the bottom. Right? Read it like a book, left to right. Right here I have log base b, and I have a set of parentheses with stuff in it. I need that stuff to be just single things. What do? So we're going to take stamp of a, multiplication becomes addition, plus stamp of y to the fifth. So kind of give yourself like a roadmap before you just start trying to write it. Okay, so log base b of a plus log base b of y to the fifth. Top of minus. Now, here's the trick. This has not happened yet because in all of our problems, the bottom of the fraction was just a single term. What's the bottom of the fraction here?
2 terms.
2 terms. We have a problem. Please take your pencil and group the bottom kind of like it's in a block so that you'll remember there's 2 things here. So when I go to expand them, it needs to stay as an entity inside a set of parentheses. Here's what I mean by that. It wouldn't really matter if it was a plus sign, but it's a minus sign, so it matters. Parentheses. Let me color coordinate this. Parentheses. Log base b of this mess. This is multiplication, so it's going to expand into addition. So it's going to be log base b of m cubed plus log base b of n to the 4th. Notice my blue parentheses. That gives the indication these 2 logs were actually a single log in the bottom of a fraction because it's coming after subtraction. With m cubed times n to the 4th in the parentheses. Now, there's 2 ways to move on from here. You do have this minus sign here, which would need to distribute. You also have a lot of what in here? Exponents that have got to come to the front. So, like I said, you'll always see me draw the arrow to say to myself what to do on the next line. And then I'm also going to account for that negative in front of the parentheses. So this would be log base b of a plus 5 log base b of y minus 3 log base b of m. What is this going to be? Minus 4 log b of n. So you might want to make a note. Careful. The careful part here was the bottom had multiple terms, so you had to group them, and then at the end you would distribute that negative to those terms. Standard rules of distribution apply here. That's a -1. This is a positive log. It would become negative. That's a negative times a positive. It would become negative. Okay. All right, now that was practicing single logs or expanded out as in expanded form. Now we're going to do expanded logs written down into single logs, which is, in my opinion, easier because there's less writing, and you know the goal is a single log, right? So let's look at it. Expressed as a single logarithm. Read the question to remind you of the goal. The goal is a single log. Look at your picture, at your expression. Take your highlighter and highlight the log and base. Because now you are going to visually see, my final answer should be log base b of something, right? It's the something part you got to figure out. The first thing you do is the last thing we did when expanding. What's that?
You put the exponent.
The coefficient needs to move back up to an exponent's place. So now I feel like we're doing the cha-cha slide. You're going to reverse. You're going to reverse the arrow to say, okay, that 5 needs to go here, and if you need to write it, so you don't accidentally write it as a times 5, you know. There's no coefficient here. There is a coefficient here. That's going to be a 1/4. It would be helpful if you know that 1/4 means 4th root. You need to know that. All right. So now I'm going to write. I don't like, when you're doing this, do one thing at a time. Okay. Don't try to do everything in one step because then you are going to get confused or frustrated or stressed out. I have log base b of x to the 5th minus log base b of y plus log base b. We already said that is the 4th root of z. All right, now what you're going to do is you're going to read it like a book from left to right. Always, and it would really help if you do this, you're saying to yourself, okay, I'm going to focus my attention on the first two. Focusing my attention on the first two. Subtraction becomes a fraction. Use the rhyming word so that you'll remember, because I'd hate for you to go write a division symbol like dot, line, dot. It's a fraction, right? Okay, so this would become a single log, base b, fraction. What goes in the fraction? X to the 5th goes on top, and what goes on the bottom? Y. And if you want, you can put that in parentheses so you don't get confused that is the of part. Have I done anything with this log? No. Then bring it down right behind it. This is a slow maintenance technique where you are just working on first two, bring it down. First two, bring it down. Now what we have, zoom out, we have log base b of something plus log base b of something. We need this to become a single logarithm. There's the only two left. I'm drawing this to help you remember. We're condensing it. It's going to be log base b of something. What goes in the something? Look in between the logs. What is it?
Multiplication.
Well, plus translates to multiplication. So x to the 5th over y times the 4th root of z. You might be thinking, where do I put the 4th root of z? Do I put it in the top or do I put it in the bottom? Well, what's understood to be over? A 1. So don't dare put it in the bottom. The 1 is in the bottom. There's an understood 1 right here. If you need to write it, then write it. So now I can see, okay, I got x to the 5th times the 4th root of z. That's z all over y. Yes, that's the single logarithm. We weren't solving. We're just condensing. This whole section is just condensing or expanding. Next section is solving by way of condensing or expanding. All right, last one. I personally like when it's ln because there's no base. I love when it's ln. It is log base e, but I just have to worry about ln. If it helps so that you don't get crammed with all the different things, just remember this is a block ln of something minus ln of something. We are going to condense this, and I say condense, like that ln and that ln are coming together to form, by their powers combined, they're forming a single ln. How do you know what to put between the ofs? It's the fact that it was subtraction becomes a fraction. Did that on purpose. All right, so it's going to be ln fraction. What goes in top? 3x plus 1. What goes on bottom? 3x squared minus 5x minus 2. Now here's the college level part. That is not in simplest form.
You're going to make it simplify it.
You might be, no, don't you dare. Shame on you. But I'm so glad you said that. Can I use it as a teachable moment?
What did Garrett say?
Please don't come in here and do this. Oh. Sorry. Please don't. He's like, I didn't do that. Please don't go in there and say the 3x cancel. They are linked by plus and minus signs. Those are terms. That's a polynomial expression. The only way things cancel out of polynomials is in factored form surrounded by parentheses. The whole thing has to match.
Or gives a factor.
That is what you meant. All right, we are going to factor this. The top is already 3x plus 1. Let's look at the bottom. 3 times negative 2 is negative 6. Factors of negative 6 that add up to negative 5.
Positive 1 and negative 6.
Wait, you said that.
Oh, yeah.
You said positive 1 and negative 6. Yeah. It's the way you...
I swear Garrett said.
He said positive 1, negative 6, and she said negative 6 and 1. They said the same thing. Very good. All right, let's come over here and work on it to the side. We have AX is 3. 3X, write the number. 3X, write the number. Remember this? This should not be old. Wait, this should not be new. Y'all, I'm done. I'm so done. I'm like, this one will reduce to what?
I don't even know.
Stay with me, please. 2, right? A 3 would divide out. And then this one comes down. It's already done. So now I'm going to rewrite this.
So it's going to be natural log of 1 over x minus 2.
3x plus 1 on top. On bottom, we have x minus 2 and 3x plus 1 here. What happens? What cancels? Be specific.
3x plus 1.
Thank you. And then what's left?
X minus 2.
Where, though?
In the bottom.
I did some stupid. I divided. I saw that.
Get me out of here. You'll see Coach Walker. I'm going to sleep.
Maybe you did divide it, right?
I don't know what you're talking about. We have an appointment with Mr. Cummings and maybe Mr. Delgado. I did say it was no cancel. You say it was stupid.
Yeah. I don't even know how you
I want the edged.
I just saw Bernie.